3, 2, 1, 0. All engine running. Liftoff. We have a liftoff.
Hello, fellow space enthusiasts. My guests this week are from Exo-Space, a startup offering a platform for on-orbit data processing. So basically, edge computing in space. But that's becoming quite a popular topic these days for a variety of reasons. Not the least of which is that we're generating an ever-increasing amount of data right there in space. So let's see all about it.
My name is Raphael Rodkin, and I'm an investor and advisor to space companies. Just as a reminder, this podcast is for informational purposes only, and nothing should be taken as investment advice. This podcast is sponsored by Nano Avionics, a satellite manufacturer and mission integrator. Their technologies enable many space companies worldwide to offer services that improve life right here on Earth, such as providing global connectivity, conducting Earth observation, or contributing to scientific discoveries. Check them out, and also check out my episode with their CEO and co-founder. Sadly, I am not a rocket scientist, but I'm an alumnus of the International Space University. ISU offers a number of educational programs about space worldwide. Check them out at isunet.edu.
Everybody, I'm here today with my guests from Exo-Space, Jeremy, Marcel, and Mark. Yes, it's an episode with 3 guests this time, so a lot of content to come. Raising expectations here. Guys, welcome to the show, and why doesn't one of you start, basically, as always, giving us the elevator pitch on the company, and if then if the other 2 of you could also briefly introduce themselves and just talk about your different roles in the company as well, please.
Yeah, for sure. Thanks for having us. My name is Marcel. I'm the mechanical engineer, co-founder here at Exo-Space. Just a little about the company is, we provide decision makers with near real-time space data. And this is accomplished by processing the data on orbit, or what we call edge computing on the satellites. So our primary product is, we call it a feather edge platform. So it's a device that mounts directly onto a satellite, and it processes images directly from the camera to characterize objects or events of interest from space in near real time. It's best to give sort of an example on this. So one of our algorithms that we want to put on our satellite is a wildfire detection. So one of the issues with wildfire detection is what we call latency. So the time between when the image is captured versus when it's sent, the data is actually sent to first responders and they can take action on it. And this can range from anywhere from around 5 hours. But in that time, over 40,000 acres can burn. We're estimating that our device can do it in about 30 minutes. This is because we're able to process on orbit.
Jeremy, Mark, do you want to quickly introduce yourselves?
Sure, yeah. Hi, I'm Mark. I am the head of business development. I'm also a mechanical engineer, so I help out Marcel with some of the design work.
And hi, I'm Jeremy, the co-founder and CEO of Exo-Space. I mainly work on the software development as well as, other business development stuff with Mark.
Thanks, guys. So let's delve into it a little bit. So the problem you're solving, why is this a problem at all? Why don't we have real-time access to relevant data?
So satellites today aren't as smart as people might think. All the data that's produced on the satellite, like the raw images, have to be sent down to the ground before they're processed. And then once they're processed on the ground, they go through the internet, network, whatever, and they then get sent down to the end user. And this whole process takes time. So what we're trying to accomplish is, if we process the data on orbit directly on a satellite, then we can actually just send the data down directly to the user. And this cuts down the time significantly. And we've seen that with the folks that we talk to, companies we talk to, is if they've shown interest in using satellite imagery, but it hasn't quite worked out. And one of the reasons is data latency, or it's too expensive to access the data, or things like that. So we're trying to sort of help them with those problems.
And yeah, just to add to that, 2 big reasons we also recognized were the reason why we felt like this is the right time to be offering the solution is, microelectronics are starting to be used a lot more in space. So a lot of companies are experimenting with new products that they can use, and they're able to experiment because business models allow for that, because there are more regular launches to space. So the cost to send something up is cheaper. And the cost or the risk in using off-the-shelf components that might not be radiation hardened is also a lot more reduced. So we kind of figured, our background in space development sort of set us up for this. The first project we worked on was one that used mainly off-the-shelf components to build like a CubeSat. And yeah, so seeing how launch costs have been dropping and the opportunity to be able to process with really, really powerful processors on orbit, it all kind of came together.
Okay, but so if we peel back a little bit on one of the use cases, so we might as well take wildfire since you guys mentioned it, and then sort of the objective being obviously you detect the fire as quickly as possible. Then I guess as a first comment, that of course supposes that there is satellite there with coverage and decent enough revisit rates, because otherwise obviously your system doesn't even help, correct?
Yeah.
Right. Yeah, that's kind of obvious, I suppose. And then, okay, so if we have a satellite there that's revisiting or a satellite constellation, I suppose, which is revisiting an area of interest, or that's California or Australia or some other place where a lot of wildfires, I suppose, with sufficient frequency, then basically your system would do the onboard processing, saying there's a fire, and sort of send a simplified message back saying, well, there's a fire, basically like a processed message, rather than the satellite sending back images to a ground station where some sort of algorithm would run but either at the ground station or I guess sort of nearby in terms of the internet, I suppose. So how much of a time advantage are we really talking about here?
So currently state-of-the-art time for that is about 5 hours, and that's if you have all the systems in place to be able to do that. Different companies use different systems to track wildfires, so it's kind of sort of out to them on what they use and what they pay for. But for us, we estimate 30 minutes, and the time delay is essentially just getting over the ground station that we want. So that's where that 30-minute delay. Otherwise, it's instantaneous on when we take the image and process it. That happens fairly quickly. And then when it's over the next ground station, then we send that down. So we say how big the fire is, where it is, and later we want to then be able to predict where, based off like wind speed, temperature, where the fire is going to be spread to. And we can then send this all down to sort of first responders in the area.
Just wanted to jump in really quick. Yeah, the two bottlenecks that we're really kind of getting around it by processing on orbit. The first is when the pictures are taken from orbit, they're just sort of sitting there on the satellite waiting to be sent down. So we figured, in that time we can be processing, because that's just time spent waiting. And then the other is, when they send all of those photos down, they're sending, hundreds of gigabytes of raw data, and that all has to get sent down, and then it gets sent across the internet to a processing center, and then sent back, and then, over to the end user. So we're sending a smaller data footprint when we send it down, which means it takes less time to move all that data around and then to the end user. So those are kind of the two bottlenecks that allow us to, speed up the time.
Yeah, no, that's fair. I think somebody, I forget now, once described it to me as saying like that the entire satellite communications is still like we're in the area of dial-up internet or so, rather than a broadband connection. Having said that, so from the way you described it right now, it's almost like the bigger problem is to sort of like you're not passing over a ground station when you want to get data back to Earth. How much in your mind might that part be alleviated by some of the stuff people are currently working on, like, relay solutions, just building more ground stations and stuff like that?
Yeah, there's definitely a way to get around it with a better ground infrastructure. The other issue, though, is you're still sending a large data footprint, across internet lines on the ground. The other thing is, one advantage to our system is by processing on orbit, we're able to send that data directly to a customer. So if they had their own ground station, their data could be totally secure instead of traveling over public lines by sending it directly to them. But yeah, I mean, it's a good point. There are edge computing systems that are on ground stations currently and building out the ground infrastructure. But this is another way, and that solution is also kind of Earth-centric in its solution. If we're talking about building processing centers around the moon or around Mars, I think it's going to be a lot harder to build like a really good ground infrastructure in those areas.
So probably asking a lot of dumb questions, but I'm curious. So when you decided on the architecture, so you guys obviously decided for this, what do you call the feather edge, which sounds like it's almost sort of like an add-on module for a spacecraft platform, right? I guess one other potential architecture would have been that you have your own, call it like a data center in space, right? You could put something in MEO or GEO, where basically then you collect data from various system customers and process it there and then send it back. How did you guys think about this sort of like architecture decisions?
I'll jump in really quick on that, Marcel, and then you can fill in. Yeah, so we actually did think about that originally. That was our original design with edge computing. And, we started pitching that around for about a year. And we talked to a lot of different companies, and they were interested in the idea, in sort of a high level, but they didn't really see the use cases for them, like right away. So we decided to even funnel down edge computing even more into like one specific aspect, which is how we decided on machine vision. We figured, there are over 50% of the satellites being sent up are Earth observing satellites. So you're generating a lot of data, a lot of image data. So if we focus on machine vision and then we use the architecture and technology we develop in that stage to move into a data center edge computing stage, then that makes a lot more sense as those steps progress. Marcel, did I miss anything on that?
Just one other thing is, our product can be sort of add-on for other satellite manufacturers that want to be able to do edge computing, but we're also planning to launch our own satellite with this device next year, and this will be in LEO. And on this satellite, we're going to host our own algorithms on it. So one of them will be fire detection. We're also going to monitor illegal fishing, ocean garbage tracking. So these are all companies, nonprofit organizations that is really interested in just the end data. And we're going to be able to provide that to them with our own satellite.
That's really interesting, because it's sort of like it's something that happens very often when you mentioned when you're originally going around and people didn't see the use cases. It's, I guess, quite common if you come up with a new technology, a new use of a technology, that you may have to do some of the initial apps yourself. So that makes a lot of sense to me. But let me take a step back here. How did you guys originally come up with this? Like, why did you start this company?
Well, so Marcel and I met in graduate school. We got our graduate degrees in astronautical engineering. We were friends in grad school, and our skills were pretty complementary. He's a mechanical engineer. I'm a software developer. So it kind of made sense that we would start a company. It was something that I've always wanted to do. And, through our experience in graduate school working on small satellites and really learning about satellite components and satellite missions, it felt like there was an opportunity in space. There's a lot of SpaceX launches, dropping. They're basically like a bus route to space, dropping the launch costs. So, we kind of felt like there was something there. So we started exploring after graduate school what we could do. And then Marcel went to be a Disney Imagineer. I went to JPL for a bit. And then we kind of just were thinking about how we could improve space technology. And one of the things that when we were pitching around, one thing that kept coming up from investors was the idea of edge computing, not edge computing in space, but just edge computing in general. So taking our space background and this new idea of edge computing, we really started diving into it to see how that might be useful. And once we kind of realized what this technology was, it sort of made sense that it lent itself really well to space, because, there is a lot of data latency. And like you're saying, I really like the analogy of broadband. Like, we're kind of in the broadband stage of data transfer. And also we started looking at the market in like 3 to 5 years, there's going to be over 1 million times more data generated in space every single day. And so really, if you want to operate a constellation in space, you're going to have to do some sort of data processing at least to send that data down. So yeah, does that cover it, Marcel?
I think so.
Yeah, I think that's fair enough. And of course, in the data latency, I mean, you guys are now understandably focused on where most of the commercial activity is, which is, I suppose, in low Earth orbit. But of course, the further we go away from Earth, arguably the more important edge processing becomes, right? So if we, take an extreme case for now, it's just science. But, if you have a Mars rover going around, arguably there would be some advantage to just processing some stuff on board, I guess.
Yeah, definitely. Yeah. And, even for low Earth orbit, there are a lot of use cases. We talked about machine vision, but even for, talking more about general purpose edge computing, if you look at like constellations of satellites at, 40, 50 satellites, and if each of those satellites is sending data down that is like just their health and status data, so the people on the ground can monitor it, 95% of that data is good data, which is really like useless to them because they're really only interested in the bad data that comes down so that they can take action. So if there's like a data center up there, or even a localized computing device that's just monitoring that health and status data and watching the trends, then you can basically use it for predictive maintenance and replace a satellite, tell when a satellite's going to go bad before it does, and replace it to get more efficiency. Yeah, those are kind of the other LEO use cases that we're thinking about.
Yeah, I was also thinking, like, if you're talking about sort of Earth observation imagery, optical imagery, right? I mean, all of the stuff that's has cloud coverage, right? Which basically isn't good for anyone, right?
Exactly. Yeah, that's another great one.
Okay, good. So let's talk a little bit about the hardware product you guys came up with at the moment, the Feather Edge. So how should I imagine that? Like, what's the sort of size and weight of that? What kind of satellite, size class can it tag on to? What kind of power does it draw from the bus, and some of those things?
Yeah, for sure. So we can start with the size. So if people are familiar, it's a half a U. So these are CubeSat units, essentially maybe 2 or 3 loaves of bread in size. Or sorry, not loaves, slices of bread, 2 or 3 slices of bread stacked. That's probably around the size of it. In terms of power draw, that's all pretty much coming from the processor that we have on there. So we're seeing about 9 watts nominal power draw, which is sufficient for a lot of 3U CubeSats, and it's fine for most, anything larger than that can handle it. One of the proprietary things about our device is essentially the shielding around it. So we are using a COTS hardware, and the problem with COTS hardware is radiation. So there could be total ionizing dose. There's single event upsets where there could be high current events, bit changes, things like that. And these will all interrupt, the processing, could corrupt the data. And one way around it is essentially building, a shielding around it. So we have various layers of material, and this can help reduce the risks for that. And then we also have different electronic components on there that and software mitigations as well. So it takes a lot of thinking of what can be done to help alleviate that.
Yeah, it's interesting. That's actually one part I was asking about, is the sort of how you deal with radiation, which even in low Earth orbit, let alone deep space, is obviously a factor. And I guess there's basically 2 ways of going around it about it, right? One is you basically go for radiation hardened chipsets, right? Like companies like Xilinx or Ramon Space or others are producing, or you go for COTS and try to shield it. It's sort of how did you guys go about that decision?
Yeah, so we did a trace study on it. Primary reasons why we went with COTS is the cost. It's very expensive to try and purchase radiation components. And then another reason is sort of the flexibility of our system. So we can actually switch out different processors or something if we wanted to, if we wanted different capabilities. So right now ours is very efficient for machine vision, but if we want to do generalized computing, we might pick out a different processor, and we can do that very easily with our system, compared to if we have to go find a rad hardened part. It might be harder to find. Another reason is that the processors that are COTS are the, I guess, top of the line one. They're the most advanced compared to the radiation hardened ones, which might be a few years old, because they're going takes a while to go through that manufacturing process, research manufacturing for the radiation hardened parts. So those would be the main reasons why we went with the COTS route. And as we build larger and larger systems, then we're not hindered by waiting for radiation hardened chips. We can just use our same concept of the shielding, software, electrical mitigations to essentially build out larger and larger pieces, where we eventually get to like a full data center that we can send up.
And so the way literally we could imagine this is you don't have to give us the specific specs, but like you take something like even like an NVIDIA off-the-shelf processor and you shield it and something like that.
Okay. Yeah, exactly.
And is that part, have you tested that in space yet? Or if not, then what is your timeline sort of for testing that in space?
Yeah, we have not tested in space. We've done some analysis simulations on the ground. Our timeline currently is next year. So June 2022 is when we'll be testing it. There has been other companies that have tested COTS hardware in LEO with some success, I believe. So we know it's possible. And then, so once we test our own system and we can prove out that either we have no events, or if there was an event, then it was able to be mitigated very easily with our system. And then once we go to LEO, then GEO is sort of the next where it's even more radiation. So we like to test it out there, and then deep space you get even more. So LEO is a good start for, if that works there, then we can move up.
And the test you will conduct in mid next year, what exactly is it? Is it like a full Feather Edge unit with already some specific use case algorithm, or how should we imagine that?
Yeah, it'll be the full system, and then we'll have at least 3 or 4 algorithms on there. And what's nice is that we can host all of them at the same time, and we can switch between them while in orbit. So say we're over California, we detect fires. Then we're over Southeast Asia, we do the illegal fishing monitoring. We're over the Pacific Ocean, we look for garbage tracking. So it's a very flexible system where we could switch between algorithms while in orbit.
And what is your sort of business, or like, I should say, revenue model on this? So I mean, I could imagine like a variety of ways of doing this, right? One, you could just sell the unit. Another thing is you sort of like place the unit and sort of charge a almost like a rental fee or something. Then you could have a sort of a service, but it's basically by the amount of processed data. How are you guys gonna go about it?
Yeah, I'll let Mark jump in on that one.
Sure. Yeah. So you're exactly right about that. So kind of our first thought was, let's just sell this unit to operators of satellite constellations so they can process their own data, one-time fee for the hardware, and they can deal with developing their own software. And then we kind of realized that that there was a really good opportunity for recurring revenue by offering the service of operating our own satellites and selling the data to companies that are just interested in the data. And as of right now, that's kind of our biggest source of revenue. We found the most traction in customers that don't really have a vested interest in space outside of just getting that data that helps them with their business back on Earth. And so those are kind of the two paths that we have well defined right now. We can see that there are some other potential revenue models, but at this point, that's kind of our plan for the near future.
So you would basically operate your own satellites with some use cases you identified as attractive ones. And but is it something, would you decide the use cases, or based on what you're seeing in the market, or is it sort of, would you wait for specific specific customers to solicit a specific use case?
Yeah, generally we're going to wait for a specific customer to say that they're interested in a use case, and we're also even going a step further than that and looking for companies that have already developed the software basically to detect whatever it is that they're interested in finding, and they can just use our satellite platform to host their model. So what's cool about our system is that we're actually able to update the software while it's on orbit. So we can update the current models, upload new models, and like Marcel said, switch out between them while we're flying.
And then, so I suppose especially if the customer supplies the classifier, the algorithm, then really it's up to the customer. It's not like you need to give any sort of accuracy guarantees or anything on the software if the customer supplies it.
Yeah, right. That at that point, they're basically just paying us to host their algorithm, and we're pretty hands off. So that's a nice use case for us. But part of our selling point for a lot of our customers is that we develop really high-end models very quickly.
And so it sounds like you guys are basically going for your own satellites, your own spacecraft. Have you guys thought about hosting on other people's satellites? And if so, what's the decision process there, going one route versus the other?
Yeah, absolutely. We're also pursuing the path of being hosted on other satellites. And it's just really a matter of what opportunities present themselves at the right time. So at this point, the way we see it, scaling is very important. The more satellites or the more units that we have in operation on orbit, the better our coverage is for our customers. So the better we're able to service them. So really any way that we can get more unit on orbit for obviously the lowest cost is beneficial for us.
So in a way, so like one of the sort of like, home run scenarios, correct me if I'm wrong, one could imagine is sort of like suddenly every planet or every satellogic satellite had one of your units on it. I mean, is that something you're pursuing as well, or have you had discussions, and if so, how have those discussions gone?
Yeah, so we have had discussions with constellation operators, and you guys can correct me if I'm wrong about this, but I believe the common refrain is come back to us when it has flight heritage. And so it's definitely something that we're kind of keeping our finger on the pulse, and always looking out for those opportunities. But I think it's also not a necessary thing. There are enough independent satellites and enough opportunities for us to launch our own constellation that sort of opportunity is not going to make or break the business.
Yeah, and also in my mind, I guess a big home run, like probably the home run solution is being able to host, like 20 different customers on our satellites, and we're constantly switching between, because those are, if like a company that operates a constellation of satellites has one unit, that's kind of a one-time sale where they're just integrating. But when we have a model where we're charging, X amount of dollars every month for each customer to use our satellite for information, that can scale way more, exponentially more than hardware units. So yeah, I think having a flexible software with multiple customers is going to be the best thing for us.
Understood. How do you see the competitive landscape for this activity?
Yeah, so right now it's kind of an interesting field to be in, because there are a lot of, so we see ourselves as like a data company, a space data company. So there are a lot of companies operating in the space data market right now, but it's still highly fragmented because it's very new. So, there are companies doing, cryptography in space. There are companies doing, general purpose edge computing. There's us doing machine vision. We sort of fall into a special fragment, but what I think is going to happen is in the next couple of years, a lot of these companies developing technology for space data are going to consolidate and start, producing more general purpose solutions in space. And once that happens, I think that's going to be very attractive to, cloud computing giants like IBM, Amazon, Microsoft, who already, operate in a $1 trillion global cloud computing market, and who are kind of looking for the new areas to compute. As far as the competitive landscape goes, we don't really have any direct competitors, but there are competitors who are operating in space data, if that kind of makes sense. It's a little weird point, but
yeah, no, that does make sense. And I guess then coming back, talk about the customers. So especially if you go to specific, it sounds like end user groups, right, with very specific use cases. I mean, at least in my experience, we still seem to have an issue with many of the end user customers that they don't really know what is possible with space data, what kind of space data there is, how it can be analyzed. I mean, is that something you guys also run into? And if so, how do you deal with that?
Yeah, for sure. We definitely run into that problem. A lot of the customers we've talked to actually they've known about Earth observation, or they've looked into it, or maybe tried it for a little bit, but it just didn't work out. And some of the reasons was the response time. It just wasn't fast enough for their use cases. There's a lot of issues between, one company will provide the image, another company then has to process the image. It's easier for them just to consolidate everything under one umbrella. And that's what we're trying to make it easy for the company. They just want the data. They don't care how it gets to them. It is a little bit about educating them in terms of what our capability is and how we can improve based off what they've used in the past.
Yeah, that's a good point, Marcel. That's what I was going to add on to is, a lot of the first customers that we've found, they kind of realized immediately that they were an ideal customer once we told them about our product. For example, one of the customer in Southeast Asia that monitors illegal fishing activity, when we reached out to them, they were immediately like, let's get on the phone, let's talk about, what we can do and those, solutions for that. So it is there is some education that has to happen for our customers. But yeah, I think the biggest thing, like Marcel's saying, is that the information as a service is what they're interested in. Like, how many ships in this area are questionable, or what type of crop is below. That's what they want to know.
A common refrain, not just for our kind of space data industry, but for new technology in general, a common refrain is, this seems like a great idea, but I don't think X market is quite ready for it, which basically to me says, this needs to be proven. I need to see it in action. I can't remember where I heard this, but I heard a great analogy of the iPhone. before there was an iPhone, no one could possibly conceive of all of the use cases and the gigantic popularity of, I mean, any kind of smartphone, but specifically the iPhone. But now you think about the iPhone, like what would the world be? I mean, probably about half of the world's mobile phone users use iPhones. And so I think you're going to see, as various instantiations of this kind of technology are proved out over the next couple of years, you're going to see it get more and more common. And like Jeremy was saying, a lot of the tech giants, I think, are going to kind of step into it either on their own or by buying up companies like ours.
So if we come back, sort of review your favorite or sort of top use cases you're focused on. So I heard wildfires, I heard illegal fishing. What would be a couple of others to round that out?
So another one is ocean garbage tracking as well. So there's piles of plastic in the ocean. Problem is that they move around from day to day, and the piles aren't like huge piles, but so they're kind of more scattered around, and it's difficult to know where they are. So boats just have to sort of follow either images from a few days ago that showed the plastics, or they put tracking devices on nets as well, and the nets can sort of pile up in the same location. But they were really interested in our sort of real time tracking, because they can get the location in a few hours, and then they can use their boats to go intercept. Another one is cloud detection as well. So we want to be able to detect which images have clouds, and then if it has the cloud, then we don't have to downlink it to the ground.
And then another more space-focused application is on orbit rendezvous and proximity operations, or RPO. Yeah. So we're actually working with a company, Arcasys, to help them develop their RPO software. That's another kind of separate developing market, the on-orbit servicing marketplace. That's also probably going to be a big deal in the next couple of years. There's a whole host of on-orbit machine vision applications that we're kind of just starting to dig into that don't necessarily have a strong commercial application at this point, because the satellite hardware in general just isn't on orbit yet. But a couple years down the line, it's definitely going to be an active marketplace.
It's very interesting. I was actually going to ask you about the RPO, because the satellite imagery stuff, that's sort of clear to me, but I do agree RPO, because depending on what you do, well, RPO, and like you correctly say, out of orbit services, because depending on what you do, again, it's really just almost no other way than to compute it on edge, because you just don't have the time, right? Because of the speeds that might be involved. I guess another example would be collision avoidance, debris, stuff like that.
Right, and that's a big use case that we're kind of digging into, space situational awareness, or SSA. So right now, the infrastructure that's in place, so the top of the line satellites do have some onboard data processing and have sensors that will tell them, this is 100 kilometers away from you. That gets sent to the ground, and then the ground operators make maneuvers to avoid whatever it is. But there's no instantiation of a satellite basically being able to say, here is this piece of debris, this other satellite that is X number of kilometers away from me. I should perform this action all within the span of 30 seconds or something like that, basically as soon as it gets the data. And so that's one of the big general use cases that I think any satellite operator could and should be interested in, especially where LEO in particular is getting so crowded.
Yeah, so I was going to say, if we have tens and tens of thousands of satellites up there, it seems like there should be some sort of autonomous capability. Otherwise, we may really have issues. So coming back to one of the imagery use case, I guess another one where time is of the essence, so to say, would be certain national security military applications.
Yeah, absolutely. So we're also kind of going the government military route, applying for those grants and stuff, kind of chasing that down. So Kind of the start of the ball of yarn with all of that is security protocols. Governments are always very concerned with the security, which we haven't really started to develop yet. So in that realm, we're starting there, and then we'll kind of build upon that for the different use cases that they see.
If you looked, maybe this is for Jeremy, if you look 5-10 years down the road, where would you like the company to be? What would you imagine the company could look like?
Yeah, in 5-10 years, I mean, the biggest thing for me is expanding our technology into a more general purpose use case. So really having, like you said, data centers up in space, computing where we're doing predictive maintenance, where, there's a lot more autonomy, where, the machines are able to just talk to each other more to send down useful data without having to triple check with the ground before doing anything. To me, it's having a constellation of satellites that can do high performance computing. In 10 years, I mean, that would be at the moon, that would probably be at Mars. So places where even, latency is even a bigger issue, between the moon or between Mars. So yeah, to me, it would be expanding our technology that we've developed in machine vision into more general cases that spread beyond just Earth.
And at that point in time, if all goes well, where do you think the company might end up in terms of an exit? Is it somebody like an AWS as a potential acquirer, or how do you think about that?
That seems reasonable. I think, like I mentioned before, global cloud computing is such a big market, and we're sort of just expanding that infrastructure into space and to places where low latency data is really important. So I think big cloud computing companies would be very interested.
Okay, but before we go to the end of the timeline with the exit, obviously you have to raise money along the way as well to finance your construction of your satellites and so forth. So you went down a sort of non-traditional route because you are listed on Spaced Ventures, which is a crowdfunding platform focused on the space sector. And for full disclosures for listeners who may not know this, I'm a member of the investment advisory committee at Spaced, just to mention that. So how did you guys decide to do that?
Yeah, well, for us, it was really a no-brainer once we realized that it was feasible. We hadn't really considered it when we were looking for more traditional financing, but we started looking at crowdfunding and met Aaron and really started talking about how crowdfunding could work for us, and it made so much sense. And one thing that really excited all of us was, being able to have like space enthusiasts invest in the company. Having the space community be a part of like an early stage space company was really exciting. And as of this morning, I think we have 106 investors in the company, and it's great for us because our network didn't expand by 106; it really expanded by everyone that those people know as well. So it's been great for us to get introductions and kind of plan the next stages of the company. I think I would encourage any company who is considering crowdfunding to really do it, because it's a great way to get an early stage financing.
It's great, and we'll put the I should know this, but the space campaign, I assume, is still open, right?
Yes, it's open until December. So
perfect. So we'll put the link in the show notes if somebody gets excited and wants to take a look. Guys, let me wrap up with my sort of typical questions at the end. One is, so if you guys didn't have this idea for Exo-Space, and you were to do something else in space, assuming you're still excited about space in general, is there any sort of other business you would be excited to do? Any other area you would look at for ideas?
Yeah.
go ahead, Mark. Go ahead.
Something that's really interesting to me is space habitat, like environments where life can grow in harsh conditions. And as a mechanical engineer, the structural elements and kind of the ceiling and all of the logistics that go into the ventilation and what have you of those sorts of structures are really interesting to me. So that's probably what I would aim to work on.
That's actually interesting. There might even be an ultimate link, because if we're in a very far away place and you're talking about sort of habitats with let's call it autonomous life support systems, for humans, but also for growing crops and stuff like that. Again, we will probably need edge computing.
Yeah, absolutely.
So Marcelo, I think Marcel maybe also wanted to say something.
Yeah. One thing I would explore would be on-orbit assembly of structures. So obviously we're limited on Earth by how large we can build, say, a telescope or something. And you see by the James Webb Telescope, have the issues having something that large. But if we could assemble something on orbit, we could build like giant structures that can do things that aren't possible right now. And that's probably the structural mechanical side of me talking as well, because it'd be interesting on how to figure out how to do that on orbit.
Yeah, and for me, I'm really interested in autonomous systems. So I think anything operating remotely. I think like resource mining is very interesting, and developing systems that are intelligent enough to go out and collect useful resources is a really interesting area.
So I guess the nice thing is that all three of the use cases, the three of you mentioned, all have a use for edge computing, basically. I mean, if you want to construct something on orbit, right? And let's say you want to you have some robotic arm that connects one truss to another truss, you probably need edge computing again, just to not mess that up and have it smash.
Yeah, otherwise it'd be a long process, because you have to keep talking to the guy on the ground saying, yes, that's fine, we can move 1 centimeter.
Exactly. Guys, and then the final question I was close up with is science fiction, and whether you like science fiction and what's some of your favorite science fiction.
I can start with that. Oh, sorry, Mark. But so mine is time travel. I love any shows or any movies that sort of explore time travel. I like how each of them has a different set of rules for it. There's no general rule about it. See, most recent Avengers Endgame had their own time travel theory, Interstellar, even Star Trek, things like that. So whenever there's a show, movie with that sort of concept, I definitely enjoy it.
Yeah, I like kind of multi-dimensional sci-fi and stories about entities or whatever that exists potentially outside the realm of standard dimensions. One in particular that comes to mind is Annihilation. That's a movie based on a book series called the Area X Trilogy by Jeff Vandermeer. Really kind of out there and gets into biologically melding a bunch of disparate life forms, and really interesting stuff.
Sorry, I've got a siren coming by. So for me, it's the Rama series by Arthur C. Clarke and Gentry Lee. I read that series a while ago, and it's probably one of my favorites. What I really like about science fiction is the opportunity to explore philosophical ideas and ethics and moral philosophy through a really interesting lens where it's kind of less in your face. And so the story is, it's about an alien starship that comes in on this cylinder that's 50 kilometers long and 20 kilometers wide. And, the humans go and explore it, and kind of the whole series unfolds from there. So it's really good.
Yeah, certainly. Rendezvous with Rama, I recommend to everybody. It's sort of one of the absolute classics of sci-fi literature. Guys, thank you so much for stopping by today. It was very interesting. Best of luck to Exo-Space. Best of luck with the crowdfunding. And again, we put the link in the show notes. And maybe we'll do this again in a year or two and see where we stand.
Sounds great. Thanks, Raphael.
Thanks, Raphael.
Well, that's it for another nominal episode of the Space Business Podcast. If you like this podcast, please consider giving it a 5-star rating on your favorite podcast platform, such as iTunes. You can follow us on Twitter at podcast_space. Also consider supporting us at www.patreon.com/spacebusinesspodcast. If the podcast got you interested in learning more about the business opportunities in the space economy, check out my new online course on space entrepreneurship on udemy.com. The link is in the episode description. Lastly, if you have any feedback, including ideas for guests, and that may include yourself if you have an exciting space story to tell, or interested in being a sponsor, drop us an email at spacebusinesspodcast@gmail.com. I look forward to seeing you for the next episode.